Welcome to another video and episode on my Arduino Yun. Previously I replaced the switch and I changed a bit of wiring because I got no signal suddenly from the Yun. The question is why, and using a multimeter to check for frequency is not the ultimate way, not the optimum way. Using an analog multimeter doesn't show anything except when it comes to resistance or voltage or current. In comes an oscilloscope. So with this probe I hope to get a little bit more clearance. This probe is for the yellow signal and this probe is for the blue signal line. But in order to do something I first have to give some input, and if you have seen my the videos on my Arduino Yun, then you know what is coming next. Giving input. And giving quite a bit of input, but now I still have to measure. So that is coming next. You see one LED burning. I am turning it, well, I'm turning the left one to the right, and then you'll see things happen. And the question is why things do happen. You can see, right, I should have known. And you can see that the left propeller is moving a little bit, so that is working. But now I want to know and see something on the oscilloscope. So will I? Well, that is a big question. So let me probe something. I do something, but is this what I need to see? That is a very big question. I have no idea actually. And is it what I want to see here? Here I just see some higher Ooh, that is not what I envisioned. Careful with the wiring. Alright. Anyway, it is supposed to give to show a pulse width on the oscilloscope. But well, apparently it doesn't quite do it that way. And it is also remarkable that in this position, where it is actually more or less on a division moment between the left and the right LED, I hear some squeaking noise. I didn't hear that one before, by the way. Anyway, what shall I probe? Oh, this is remarkable. No, it doesn't do anything. Probing it doesn't show anything. What? And now, what is happening anyway? Alright, turning it down. Wonders of engineering, but how? Good question. How do I get that signal? And how do I get this continuously working? Exploration. Okay, I changed a little bit. Well, not me of course, but the setup. So let me show. This line is going to this transistor coming from the Yun with a certain pulse width. It proved to be next to impossible to connect the probe to the transistor, so I decided to put a little piece of metal from a staple in the same lane and connect the probe to that. Then I wanted to do the same for this transistor circuit, and actually did exactly the same. So a piece of staple in the same lane and connect the probe to that. And this is what you get. So the question is, what is it? Is it a pulse width? Is it something else? So let me give some input. And can I change this a bit? I don't know yet. So let me for now change the source to the second channel. Does it have a slope, or does it have a width? Good question. This is purely experimenting. Because what I want to see, and of course once again I need to give input. The point is that the scope is some distance from the computer. Alright, so, and as long as there's input you see a wild signal, so that may be a signal for me too. So anyway, let's go back to channel 1 and choose perhaps this one. What I may also do change a bit. And this is edge triggered. I'm fine with that, I think. Back to channel 2. And what's the difference? Is there indeed a difference? Yeah, well, difference I do see right now is that when there's no input, you can actually see this. But I can't see that here at the blue line. So let me change channel again. Slope, well, that's actually the same, I think. Or is it? Yeah, they're the same. Give some input. What I want to see is some nice thing in this form, so I can check on the pulse width. But so far I haven't managed that. Alright, let me dive deeper into the settings of the scope and see whatever I can get from it. And that may also be, it may also be worthwhile to check on output anyway on pin 9, because that failed me. Yeah, these are nice experiments. After studying the manual of the oscilloscope, things are getting a bit interesting, and more interesting than they were. Point is that there are, of course, all kinds of settings, and most settings indicate that, for example, a downslope is shorter than a upper slope, or that the down pulse width is wider than the upper pulse width, to mention something. But you can also set a pulse width of some nanoseconds, microseconds, you name it. And that comes directly down to what is the pulse width, because I am dealing with pulse width modulation. So dealing with pulse width modulation means that you set a certain pulse width, which comes down to a frequency, but then a pulse width which can be measured here on the oscilloscope. But then, what is the pulse width? What's the period length? And that is a very good one, because looking from frequency point of view, a frequency is the number of periods per second. So 1 Hertz is 1 full period in a second. Means up, if you follow the cursor, a pulse is then up and down. That's 1 period. If that happens in 1 second, you have 1 Hertz. 1000 of those periods is 1 kilohertz. Now, if you have pulse modulation, you do not have a sinus, but more like blocks, and you will have then a pulse width of over 50%, you get a higher speed than if the pulse width is a very small one. So with that consideration, how to deal with this? Should I neglect any negativity? Because right now it certainly looks like it is going down and up, but I do not have yet an image of a nice block pulse. It is more like sloping. So that's a point that I need to find out. And this here you can see the width, but also a greater than. So looking here, this is a down pulse, and I think I need the upper pulse. No, this one. By the way, I'm doing channel 2, so the blue line. And the setting, that's a point, of course. What is the pulse width? And I think I'll have to calculate that from all the data that I put in. So, for example, our value 2 is 0, but here I put all these values in that I calculate somewhere here. So that's going to be a challenge. What is what? Should I actually put this out and put some values in? Like I do here, analog write 512. And what belongs to 512? Very good question. Time to find that out. When you have an idea, it is always a good idea to actually look at the code again and then find out which value you are using or getting. And here output value 1 is being derived by sensor value, and sensor value is being read from A0. That is actually output value 1. So you get here output value 1, and then where do we have output value 1? Right here is 217. Well, nice figure. However, what's the frequency? Well, to find that, I once again took the multimeter hope to improve the lighting, and I measure right here with the probe, and I get right now some 500 Hertz. varies a bit. So let's go once again in here. Measure again. Oops. Careful with the wiring. Well, let's say 500 Hertz. And in setting this up I measured a little bit different, but let me once again do it with some values. Once again some 500 Hertz. So what to do with that? Well, let me take maxima again, change it to 500 Hertz. Actually 500 periods per second. So let's see about this one. Yeah. To float 2/1000 of a second for one period. Alright, nice. However, no, not this one, this one. If I look here, it says for channel 2, and that goes probably for channel 1 as well, is 1 microsecond. And 2/1000 of a second is actually 2000 microseconds. So what can I do about that one? That's going to be I'm not quite sure how this is being derived. If this is even possible, well, because now I am at 2.35 microseconds, and that is a very far cry from the 2 milliseconds. So how am I going to do that? That is a very good question. And now for an answer, even a better point. Actually, from the manual, it turns out that the range available is from 8 nanoseconds to 10 seconds. And we're talking our pulse width setting. And for these settings, whatever they are, range of the power lower limit is from 8 nanoseconds to almost 10 seconds. Question is how to put that in. Endlessly turning the knob, I think you'll agree, is not an option. So let me of course. So I need 2 milliseconds. No. Hold on. Delete. 2 milliseconds. Did I do this correctly? This is seconds. Two. No, I do it again wrong. It's a constant slip of the finger, but let me... Now it's 2 milliseconds. And this actually looks like something. Now stay off this one. So how to correct this one? I'm not quite sure, but the periodic seems about right. So then what is the measurement of the other one? Let me give it some input. Measuring gives something unreadable. And this one has to stay in its place. But the reading from this one is actually not what I expected. Because this, alright, the first reading I have no clue. Some 10 hertz or something. It just goes up and down, up and down. Very hard to read something with this. So that's difficult to do. But I've at least one thing which comes a bit close to what I think it is. But is that sufficient? I dare not say actually. So what about changing this? Ah, look at that. I turn the pot meter and there it goes. Quite up. Lower, 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 lower. Oh, I have no input anymore. Oops. So there I go. Turning, turning, turning. Alright, this is a nice one. Actually a very nice one. So now I have something of a very nice situation on the yellow line. Let's get the same thing on the blue line. So I change channel. Let me put it down. So once again I change channel, then would this be the same then? it is 2 microseconds. I can always check, of course, and then I'll have to do is so this is actually pretty nice, I think. But what about this one? What is this one doing? This is clearly a change when I turn the left pot meter. Still not quite sure if I'm doing right, by the way. Whoops. Oh, what's going on here? I lost all of the signal. Yeah, because the signal is no longer there. Now it is. I can't even tell if the right side pot meter, and let me show you, if the right side pot meter is of any influence on the blue line. And let me show you here. That is supposed to start running automatically again. It does. But once again, to say that the blue line is influenced, not really. Alright, I guess that is it for now. What did I do? Well, not change any code anyway. Measure frequency. Try out the pulse width measurement with the oscilloscope. And adding a probe moment. And making sure that indeed things actually do work, or should work, because now the right side the right side LED on the right here suddenly doesn't work anymore for some reason. Now does. Well, the propeller works. Okay, anyway, thanks for watching. If you like this video, please subscribe to my channel if you haven't done so. Otherwise, you can follow me on Twitter, you can follow me on Instagram, see my website. For more information, also on donating, please do so to keep the videos coming. And lots of pictures and more information on my blog, on my website, and this is of course going to be continued. Bye bye.